everybody. Welcome to the DPIN podcast. I'm your host, Tom Trowbridge. I'm thrilled to be here today with Jason, the co-founder and CEO of Daylight. Welcome, Jason.
Thank you, Tom, for having me. I'm excited to be here.
Great to have you on. Love to hear what you're doing. It's in the energy space. If you could give people a quick heads up as to what Daylight does, can't wait to hear.
Yeah, of course. So Daylight is really at its core an on-chain marketplace for distributed energy capacity to alleviate strains on power grids. And also, as a byproduct and a core piece of the coordination mechanism, the world's first energy-backed currency, which we're quite excited about. Daylight is, broadly an ecosystem focused on distributed energy growth. The protocol is our core product. We'll dive a bit into the protocol's mechanics and how it works. We also uniquely have taken, I think, a bit of a different path into the deep end space. So we actually also have an operating company called the Daylight Marketplace, which is also the first application built on the Daylight protocol that effectively standardizes and simplifies the upgrade process to distribute energy resources for homeowners and small business owners. So homeowners can come to the platform, they can find distributed energy upgrades that make the most sense for them. And we have a marketplace of local installers ready to go to make those installations and install those resources and connect them back to the protocol itself. So the Daylight ecosystem is really a full ecosystem, both the protocol that's focused on coordination and incentives, and the marketplace that's really focused on growing the ecosystem and growing the protocol itself.
Well, listen, that's super interesting. But I think looking at this from a DPIN perspective is, there's obviously a number of marketplaces out there in a variety of sectors, right? And that's something that the crypto landscape is quite accomplished in architecting and launching. How that translates into DPIN is, is a sort of another level. And so maybe spend a little bit more time on kind of both the energy marketplace and what that actually means, and then very interested in kind of what that DPIN link is, because it's not immediately obvious.
Yeah, so let's jump into like the protocol. So the protocol again is an on-chain marketplace for distributed energy capacity to alleviate strain on power grids. And so if we give some context on the energy space today, energy is changing quite fundamentally on both the supply and the demand side. So something most people don't know is that over the last 20 years, energy demand growth has effectively been flat in the US and in most major markets around the world. And over the next 10 years, we're expected to double energy demand from AI, from compute, from electrification of massive new industries like transportation and heating. All these things are leading to an explosion in energy demand. And at the same time, the majority of the new supply coming onto the grid is renewable, which is great for sustainability targets. It's a very low cost form of energy, but it also creates complexity around forecasting and balancing the system because renewable energy is dependent on weather patterns and it's an intermittent resource. And so both these trends on the demand side and the supply side are conspiring to create less stable grids, more volatility, more reliability issues. Here in the United States, where we're based, there's actually 300% more blackouts in the United States than there were in the 1980s when we first started tracking this data. And the United States leads the developed world in minutes spent without power per capita. It's a really interesting problem. And so as we look at this problem set, people are looking around and trying to figure out how are we going to meet all this demand for new energy while ensuring the grid remains reliable. And the traditional model of energy grids is a very centralized one, right? You build massive new generation facilities, you build big transmission systems to pipe those electrons into city centers, and you serve demand where it exists. The problem with that approach is, interconnecting big power plants takes many, many years, 5, 6, 7, 8 years in many cases. Building new transmission is almost impossible just from the bureaucracy, the amount of municipalities it crosses, the NIMBYism that exists today. New transmission is incredibly difficult, if not impossible to build. And so there's a big question of where are we going to get new energy capacity to meet all this demand and also ensure that the grid remains reliable. There's an alternative, though, that presents itself today, which is distributed energy. If we, simply move generation, storage, and energy management to the edges of the grid, all of a sudden you alleviate a lot of the need to build massive new centralized generation and massive new transmission because you've effectively just opened up more capacity on the existing grid by moving existing consumption and demand to the edge. And that is a really interesting approach that eliminates, trillions of dollars in capex in the transmission system, these devices can also be aggregated and networked together and effectively mimic the role of bigger power plants. So at times when the larger grid is strained, they can dispatch together and provide that capacity back to the energy system. And it's a really elegant way to kind of push capital needs to the individual level, ensure that grids remain reliable, and increase the capacity without having to build tons of new transmission. And that's
And
really
just
kind of the end goal.
and just to be super specific, are you talking about, retail or, residential or even commercial rooftop solar as an example? Are you talking about individual turbines? Like what does it actually mean to the edge?
Yeah, so we're talking about generation, storage, and energy management broadly. So think about residential homes, think about small businesses, anything that exists on the distribution grid, generating their own power primarily through solar, storing it with batteries, and then connecting their major energy consumption devices like HVAC, water heating, connecting that back to a platform that can manage all of that together, and that frees up a lot of capacity on the grid. And so that's what we're talking about. But distributed energy uniquely has a bit of a coordination problem or a market failure by nature. And that is these benefits of distributed energy that we're talking about, um, they apply in the aggregate, right? But the investment decision to move to distributed energy is a very individual one. And so you have this issue or this market failure where because of this dynamic, distributed energy is more expensive and has lower, ROIs than it would and if the market properly valued it. And so what we're doing at Daylight with our, again, on-chain marketplace for distributed energy capacity is we incentivize with our token users to connect distributed energy resources or to move to distributed energy resources, anchor some flexibility over those resources back to the protocol. So give the protocol some level of control over those devices. And then the protocol brokers that flexibility out to energy companies, energy retailers, power traders, organizations that need access to this capacity and can use it to balance energy grids and help reduce volatility on the energy system broadly. So that is kind of a summary of the problem set and why we're taking the approach that we're taking. It's use tokens to solve this market failure, increase the return on investment and incentivize investment in distributed energy resources, and anchor them back to this common open source protocol for energy companies to plug in and utilize that capacity that's anchored.
There is a lot there. That is a complex setup. And so can you help us make it specific? Does that mean if I'm a business, I have installed solar, I connect it to Daylight, and then I by default or automatically allocate X% of my generation to Daylight. In return for that, I get some reward or some tokens, and Daylight then distributes, monetizes that energy as it sees appropriate.
That's a great summary. The only thing I would double click on is that generation is actually the least interesting part of this from a capacity standpoint. And the reason is because if we go back to the problem statement earlier, right? Renewable energy is intermittent. We can't control its output. And the value that these networks of distributed energy devices can provide the energy system is on demand capacity, right? And so generation is helpful in the sense that it lowers the energy cost for that end node who can provide flexibility back to the system. But the more valuable device connections for Daylight are things like batteries, electric vehicle chargers, big HVAC loads. So smart thermostats connected to big HVAC loads, internet connected hot water heaters. All these devices have predictable energy consumption. And the protocol integrates with them directly through software. We have software integrations with nearly every distributed energy device on the market. And those devices provide that reliable response to do exactly what you said earlier.
Interesting. So basically, you can direct stuff to go to a battery and pull from a battery when you need, or make it not just the shipping and selling, but even like the storing and the use period.
Exactly.
Interesting. Well, then we can take two ways, but and the DPIN component to this, is there hardware that you help people buy to either manage this or to generate or to store electricity?
It's a great question. So ours has a bit of a mix. So, again, we're talking about distributed energy devices. We do not have a daylight thermostat, daylight solar panels, daylight batteries. We integrate with really anything that exists on the market today. We want to build a very robust open ecosystem of hardware integrations. And so all those integrations are done purely through software. The way this works is you download the Daylight app, you select the device that you want to connect, and you connect it through a very plaid-like interface. You basically input your credentials for that device. you delegate some level of flexibility. So to be specific there, if you say have a thermostat you want to connect, you would connect that thermostat. You can actually control it directly in our app. So you can set schedules. You can just control it like you would in the Nest app or the Ecobee app. And you can also delegate that flexibility to the protocol. So you can tell the protocol, I want to give you 2 degrees of control over my thermostat, meaning the protocol may adjust your thermostat set point by 2 degrees at certain periods in time when it's selling that capacity to the energy market. Similarly with the battery, you could do something like, daylight can touch my battery, but I always want to make sure I have 50% charge my battery at all times, and we never dip below that threshold. And so the parameters are set by the user themselves. To your question on the hardware piece, we do have one specific piece of hardware that is specific to the daylight ecosystem that we require users to deploy to become full contributors. And that's actually an energy meter. So, energy metering has a really unique problem in that meters broadly across most energy markets are owned by utilities. Utilities are typically local monopolies. In the US alone, there's over 3,000 electric utilities, and there's no incentive for them to collaborate. So, there's no standardized kind of set of energy data when it comes to building consumption that a project like ours can tap into. In addition, the quality of energy data that most smart meters have today is of a lower quality than you need to run these virtual power plant type networks. Just they're built for billing. They're not built for running these distributed power plants, right? And so our meter collects standardized real time data across the entire network and broadcasts it back to the protocol. So the protocol always has a view of what's going on across all its connected homes from their energy consumption and how much of that energy consumption can be sold back to the grid in the form of capacity. So the energy meter is a simple device. It's installed in your electric panel. So it clamps on to the mains that run into the electric panel. It collects the current that's running through there. Whereas we have a plug that goes into an outlet that collects the voltage, and both that the current and the voltage information is streamed back to the protocol in real time. So we get a view of all the nodes on the network.
And how much does that device cost?
We have not set the prices formally yet. I know we're recording this pre meter launch, but I will say that it will be in the ballpark of most deep in hardware devices. So if you look at Demo, you look at Hive Mapper,
300, 500.
exactly, it's gonna be
Okay.
in that range.
And then does it require a electrician to install, or is it self-install?
Um, I'm not sure if I can suggest people install this themselves. I will say that there's major companies that sell these basically as consumer hardware devices. Sense is a major one. They sell a device called the Sense Energy Management System, and I know many people who install these themselves. I encourage people though to get help from a professional electrician if they would like.
But so if I'm understanding this right, then what the deep inside to me sounds like you buy this smart meter, it's installed one way or another. That then onboards you to the Daylight network. And that then allows you to start receiving rewards for contributing whatever portion of electricity, et cetera, that you're generating. Is that right?
Exactly.
Super interesting.
The more
And so
devices
then
that you connect, the more that you earn, right? Because the more devices you connect effectively gives the platform more control and more flexibility over your energy consumption. I think what's interesting and something a lot of people don't understand intuitively, and it really is, it takes a bit of time to sit with it to understand. But if you go back to that dynamic of supply and demand, right? Power grids are really based on ensuring supply and demand are matched at all time. And so there's two things that can happen if that falls out of balance, right? You can increase the supply on the power grid, or you can decrease the demand. And our network can do both. In certain scenarios, for example, a battery can actually dispatch and export its stored energy into the grid itself. In other cases, like with a hot water heater or with a thermostat, you're actually just reducing that energy consumption from a baseline value, and that delta between the baseline and the reduced energy consumption when you changed those devices is effectively energy that you're also reselling to the market, and the network will be paid for. So in the market or in the energy industry, we have a term that's used often called negawatts or negative watts, and those negative watts can be monetized just like megawatts that are actually being delivered into the grid itself.
Well, listen, let's talk. There's a lot of places I want to go, but let's talk about monetization and tokenization. And so, how is it you contribute? Pick your metric in terms of watts, megawatts, whatever, to the network. Are you rewarded based on the percentage that is contributed or is in the network or has contributed to the network at that time, and then you will then receive some rewards based on that same allocation. And is that then monetized like by burning when you sell electricity? I'm sort of speculating as to how a token market could work here.
Yeah, so it's similar to that concept, right? So tokens, I think our inspiration came from two sources on the token issuance side. One is Filecoin. So I think Filecoin actually has a really unique token model in that their distribution model is based on two token issuance curves. So in Filecoin, they have simple minting, which is there to incentivize early adopters. And then they have baseline minting, which is around productive storage coming to their network. And
Growth of productive
growth,
storage.
exactly. Productive growth of storage according to the baseline that they're setting. And I think that's a really elegant way to ensure that inflation is relatively productive while also rewarding earlier adopters. Hivemapper, I think, does a great job as well of balancing token rewards away from a pure time based schedule to one that is based, again, around growth and freshness of their map data. And so that is our inspiration for supply dynamics as well. We plan to have two token issuance curves, very much like Filecoin, simple minting based on rewarding earlier adopters. And it's just all about connecting devices. The more devices you connect, the more you earn. It's a very simple formula, right? So it's effectively each type of device connection gives you so many points per week. You compare that to the total amount of points of the entire network, and that will kind of give you your allocation of that epoch's issuance. I think Demo has a very similar structure to how they're issuing tokens today. On the capacity minting, it's effectively built around the capacity of the network itself. And so you can think about this as equivalent to growth in storage capacity for Filecoin. Ours is growth of energy capacity in around the network itself. So we have a mechanism we've designed called proof of capacity. And proof of capacity is a challenge mechanism to ensure that nodes on the network, this nodes being buildings with connected devices, are actively listening. Their devices are constantly looking to register a response, and the meter is picking up deviation in energy consumption based on the dispatch of those devices. And so, proof of capacity is the key input into the capacity minting formula. And you can kind of think about it, similar to like a proof of coverage reward. So it's a little bit complex. More information will come out, relatively soon as we publish our documentation in token economics. But I think most people can start thinking about it somewhat equivalent to Filecoin in the sense of simple minting and then a productive growth minting schedule.
And then what about the monetization, the network? Does the network then monetize that energy you receive, and that then goes into some level of burn of one or both of those or burn of the tokens effectively?
We're actually working on a new system with Neil from Andrina and Sal and Mahesh from Escape Velocity. The Sal actually published this, and Tom, we should link this in the show notes. If you do link things in the show notes, they released a great blog post from the Escape Velocity website on a system that we're calling the medallion system. You can think about the medallion system as relatively equivalent to a taxi medallion system in real life, right? So if you're looking to operate a taxi in New York City, you have to own a medallion to have the right to drive a taxi in the city. And you can either own a medallion or you can lease it from an owner. But as long as you have that medallion, you have the right to the underlying commodity, which is, approval to drive a taxi. In daylight, the way this works is demand is actually driven by energy companies that want access to the capacity. And in order for them to get access to that capacity, they need to hold medallions. Medallions are only minted by staking tokens into a medallion creation pool. And over time, there's a bonding curve where more tokens are needed to mint the next marginal medallion. So it kind of combats inflation by making medallions marginally more expensive through time. Whenever a energy company holds or leases medallions, they point them to a specific region, and that medallion gives them access to a predetermined amount of energy capacity in that region. The interesting thing about this model is energy is a bit different than, say, wireless, where you can just price a data packet, like in the Helium IoT network, right? You can price a data packet, you can set a standard price, and people and companies can come build and have a set price to transfer their data. Energy is a very, very volatile commodity. It's actually the most volatile commodity in the world. There's a great chart that I love to point to that plots Bitcoin's volatility against real-time power price volatility, and Bitcoin looks like a stable coin. And so power is a much different market than, say, wireless. And there's a lot of different reasons why different groups of customers want access to this energy capacity. And without getting too in the weeds, there's, internal risk management, there's arbitrage and power trading, there's effectively insurance products for the market, just called capacity. And so there's a number of different reasons and a number of different ways to monetize this capacity. And so what we say is we don't want to have to run an operating company from the protocol itself. We just want the protocol to be very, very simple. And so let energy companies decide how they want to monetize this capacity in each region. And so we don't have to worry about pricing. We don't have to worry about ensuring that the capacity is going into the most lucrative market. All we worry about is getting demand and getting licenses out to energy companies to monetize and utilize the underlying resource. And they effectively take merchant risk and can use that any way they want.
Um, Super interesting in a couple of ways, but we've obviously seen staking on the supply side. I've not seen staking on the demand side, which is what you're talking about, which is pretty cool. You're effectively saying create an auction for demand. It's kind of like the parachain auction
Yes.
that Polkadot did at one point, right? Like, so pretty interesting. Do those NFTs though, does that expire? Is it for a certain period of time? Do you have to put up an auction? How do you prevent someone from getting capacity just hanging on to it indefinitely?
It's a great question. That last question specifically, I think, is the one that we're working on right now. And so, if we think about the way that the medallions are constructed, there is no time expiration date on the medallions today. You can unlock the tokens in your medallion at any time, but there will be a time delay, just like unbonding period from a validator to get those tokens back. So medallions do not have an expiration date. They do have to be pointed to a region. So the protocol has regions defined. That medallion is pointed specifically to a region. You can move that medallion to another region if you would like, but it does have to be regionally pointed. And each medallion has a maximum capacity value in terms of capacity of 100 kilowatt hours. And so you need to have at least as many medallions as capacity as you would like. Other people may decide to stake to that region to attempt to access it. And so the way we're solving that problem, or attempting to solve that problem, is basically creating a majority rules. So whoever holds the majority of medallions in a market automatically gets the right to all of the capacity in that region, assuming they have enough medallion coverage for that capacity. And that's how we prevent someone going in there and just staking medallions to disrupt the system and eliminating energy companies being able to access some of the underlying capacity in a specific region.
But that means if a region has, pick a number, 500 kilowatts, whatever, if you have
Yep.
5 medallions, no one is going to go in there because no one wants to buy 6 medallions to cover 500 megawatts, right? So your 500 guy is fine. He's got it. He has it. If he purchased those at a low price, though, he then could be, and electricity spikes, or video here, then he could be doing incredibly well because he purchased those at a very low price. Energy spikes for some period of time. He's not getting more capacity, right? That's fixed, but there could be an interesting trade there depending on when he bought them, which is fine.
Totally. Totally. Yep.
The other thing, are you familiar with a harbinger tax?
Explain it.
So a harbinger tax is an asset, and this is something I've worked on with a partner of mine, Eric Wall, on something unrelated to energy, but where you have an asset, and that asset is always for sale at a price, but some percentage of that sale price the owner must pay on a daily, monthly, weekly basis. So every asset you put it for a price, and it can be bid away from you at that price, but you're disincented from a huge price because you're going to have to pay a tax on that, right? And the tax could be 1% to 100% to 300%. It could be daily, it could be yearly, right? Whatever. But that means that asset is always effectively in play if it becomes mispriced.
It's really funny? Actually, Sal from EV3 brought this concept up specifically for the medallion system. So it's great to hear you also arrived at the same conclusion that this could be an interesting mechanism to implement.
It is. It is. People have to understand it. And I got to tell you, I think as energy customers, they are not energy companies are not known for their cutting edge, initiatives. So it may
Totally.
be I think they buy it, they own it, it's fine. put it away. Like my hunch is you're going to get more adoption with that than as much as I love the Harbinger tax. My hunch is these customers won't want that level of uncertainty in it. But super interesting. And then that and so that effectively, the more capacity on the network, the more stake is required. And is that stake, just so I grasp this last piece, the stake is basically denominated in 100 kilowatt hour chunks, right? And so is it a fixed amount of coins, is it dollar based amount? How does that stake required or determined?
Again, we'll reveal more details publicly
Fine.
later, but I think the right way to think about this is it will follow some form of a bonding curve just to combat general network inflation, right? So as more tokens are issued through time, you want the medallion to become more and more expensive to combat inflation in the network itself. So there will be some form of a bonding curve where the next marginal medallion is more expensive than the last.
Fair enough. Super interesting. Great. Listen, let's back up. Let's talk about Jason. How did you get here? How did you found this? Like, what was the path that got you here?
Yeah, so I started my career in energy through finance. So I started my career in investment banking, covering energy and power, working on mergers and acquisitions, on capital advisory. Left investment banking after my 2 years as an analyst to go to private equity, investing at a great firm that invested primarily in service businesses around critical infrastructure. So we invested around power, around gas, around water, around logistics. I focused a lot specifically while I was there on the power side, given my background in energy and power investment banking, and had a front row seat to what is front page news today, just the coming strain on energy grids from compute, from electrification, from reshoring of industrial capacity. And just, like the problems that talked about today, it was clear to me that the centralized model of developing power grids likely wouldn't work going forward. At the same time, I had been in crypto since 2017, had been a contributor to Helium just in a personal way, running a single hotspot, but really fell in love with the incentive design of the Helium network and saw some parallels to the problems in energy and how we could potentially solve it. And so in 2022, left private equity, raised the seed round for Daylight, and built our core team that all come from a very, very deep power background. So I have very senior power traders on our team. I have folks that operated at utilities. I have folks that were certified grid operators for transmission grids. So we have an incredible team behind us that understand power very deeply and also understand crypto very deeply. And we're merging those two to build something I think quite unique and quite special.
Well, what's interesting, I mean, I come from the TradFi side as well. I did my 2 years in investment banking and private equity after that, so I know the drill. I think I did a little earlier, but what's interesting is that the number of people in energy who also were paying attention to crypto has got to be a pretty small universe, right? And so I'm sure you discover that with your peers at either of those firms or the people even when you go out to hire even the energy companies you talk to. I mean, energy is not known as a innovative industry, right? So have you seen challenges? I mean, how do you think about kind of the confluence of circumstances that brought you here versus everybody else in the industry or a lot of people who are probably much more traditional?
It is an interesting intersection. And I think that was one of the reasons I was so excited to jump at this opportunity was I did feel like I was a bit of a right place, right time kind of world where, I loved the energy space. I'd been working in it for a number of years. And I also, deeply loved crypto. And I knew that there was very few people that fit that overlap. And that made me quite excited to go chase this opportunity, explore this opportunity. I will say though, people have been thinking about this in really unique ways. I think energy of all the industrial industries is probably the most crypto attuned purely through the scale of Bitcoin mining today, right? And so they at least have some understanding of crypto, even if that exposure is fairly limited to Bitcoin. But there are people that have followed the path of getting interested in crypto through Bitcoin mining and have then progressed into a kind of a deeper understanding of what crypto can do and coordination systems and blockchains and how they can be useful to society at large. One of my co-founders, Evan, actually was a power trader for a number of years. And in 2015, 2016, left to focus on climate tech entrepreneurship. He's started a number of companies. But in 2016 and going into 2017, he actually attempted to launch a protocol spiritually similar to Daylight. At the time, it was called Switch, But the goal was to build a token network incentivizing growth of specifically solar, but distributed energy capacity. He was much too early. This is 2016, going into the 2017 boom. After the 2017 boom in 2018, the business pivoted into a business that's now known as ClearTrace. But it's quite interesting that he had been thinking about this intersection for going on 8 years now. So there are people that have been thinking quite deeply about it, and it's fun to have them on the team.
That's terrific. Thinking of, referencing that a little bit, um, anything in the development or just sort of the timing that makes daylight possible now that wouldn't have been possible, pick your time frame, 2, 3, 5 years ago? Is the device cheaper to manufacture or possible manufacture? It used to not be like, crypto economies, obviously growing up, you couldn't have done this without it. Or could you have done something similar and just sold the energy on the network? Like, tell us about kind of, is there a unique kind of timing that made this actually possible now versus earlier?
It's certainly improved. And I'll talk with a little bit of a US centric view, just that's because where our team's based. And that's the power market that we understand the best, although the protocol will be permissionless and global. But in the US specifically, let's start there. There's a few things that have really improved, I think, the odds of success of a project like this. Number one, just purely on the cost side, solar, storage, these distributed energy resources have continued down a very, very rapid cost decline curve. Solar's down 90% over the last decade, batteries about the same. It looks like that cost curve will continue to accelerate through the next decade. And so distributed energy resources broadly are becoming very, very economic and achievable for most people to purchase and deploy in their home or in their business. Second, with the Inflation Reduction Act of the United States, the tax incentives are significant on these upgrades. And so while not required for success, it is just a significant tailwind to our project. And then I think most importantly, the regulatory environment has recognized how critical distributed energy growth is going to be for the future of the energy system for all the reasons we've talked about today. And so in 2020, there was actually a pretty significant ruling out of FERC, which is the entity that governs power markets in the United States, called Order 2222. And Order 2222 basically opened up the pathway for these pools and aggregations of distributed energy resources to participate in the energy markets, just like a larger power plant. And so from a regulatory standpoint, that just opened up over the last 4 years, where these aggregations can participate directly in wholesale power markets, just like large power plants, a big natural gas power plant, or a wind farm or a solar farm. We can schedule and bid distributed energy capacity directly into wholesale markets, and that's a big change. And so the regulatory environment has recognized this problem and is welcoming projects to come aggregate resources, incentivize resources, and connect those to the broader energy system.
We've seen, you mentioned Bitcoin mining. Bitcoin mining started off with people mining out of their houses, right? Their basements. And now, fast forward, you referenced this earlier, you have publicly traded companies who are purpose built to mine Bitcoins out of massive facilities. So when you think about the growth of daylight, does it start off with consumer rooftops and then move to, complete, solar grids? Or solar farms, or does it start off somewhere in between with both a combination of commercial and retail? How do you see development kind of evolving?
I think it will always stay primarily focused on the distributed market, not these large, industrial solar farms or battery farms. And the reason for that is those assets are so large, they can just schedule themselves directly into the power market. So if you and I could develop a solar farm, we don't need to join a network of other resources to schedule and bid our resource directly into the power market, right? We can just participate directly. But the distributed market has tons of benefits, like we've talked about today, offsetting, transmission capex, increasing reliability by providing dispatchable power from the demand side, potentially alleviating congestion on power grids, all these great benefits. And so what I expect, the success case for daylight will look like is just a much, much, much more distributed, decentralized grid, where hopefully we have these networks of deployers popping up where they're running effectively organizations that go and electrify industrial warehouses, commercial buildings and apartment buildings, homes and small businesses. They're really running, these, mini sun runs, going around and connecting those devices back to the the broader protocol.
And so, do you think that daylight will help catalyze a sort of next wave, effectively, of solar installations because you are now able to monetize some of that solar effect, and without having to worry or think or deal with it?
100% solar and electrified resources, so electric hot water heaters or heat pump hot water heaters, heat pump heating and cooling units, EVs and EV chargers, storage is the big one. All these devices that provide massive flexible capacity back to the protocol is what we're seeking to incentivize. Energy uniquely has had a long tradition of what I'll call market-based solutions to solve market failures. So in renewable energy, in order to drive down the cost of renewable energy and incentivize renewable energy growth, a market for what's called RECs or renewable energy credits was created. And those RECs can be, detached from the power that's generated and sold to someone else so they can claim their power is renewable. Same thing in Europe where you are, Tom. There's a massive market in Italy and France and a number of other countries in Europe for something called white certificates, which are effectively energy efficiency credits. So a building can reduce their energy consumption and they can sell their energy efficiency credit to another organization that can then take a claim for reducing their energy efficiency cost. We have cap and trade systems for emissions. So we've had this long tradition of what I'll call tradable credit schemes or market solutions to solve market failures and create outcomes in energy. They've all been government driven. Our vision at Daylight is to look at the distributed energy space, recognize that there is this market failure where we need to increase the rationale for investment in distributed energy. And so instead of relying on governments to mandate that, we're just building the incentive program from the ground up in a very community driven way with an on-chain marketplace and an on-chain incentive. And so that's how I see the success case here is very much like the success of renewable energy credits, of white certificates, of cap and trade systems. We're building a broad incentive network that drives a massive investment cycle in distributed energy.
Really interesting. And listen, and you're doing it in a critical sector, and it's a terrific. The crypto world is criticized for the power consumption, obviously mainly because of Bitcoin, obviously, and so it is terrific to be able to point to projects that are deploying this technology to actually increase clean energy and increase energy resilience, because that is definitely not part of the crypto narrative at all right now.
Certainly hope that projects like ours and others will change that narrative and people will start to understand broadly that this is a powerful general purpose technology that can be used for many things and incentivizing many different outcomes.
You've obviously gotten very far with this. Any examples of things that took longer, didn't work, path you had to started down, had to change? Any kind of negative expectations that people can you can save them the trouble of making the same mistake, or some lessons learned that give people some stuff to watch out for?
Totally. I'm a time founder, but when I speak with new founders that are, coming after me, I think the biggest piece of advice I have is you're going to make mistakes. It's not about not making mistakes. It's about course correcting as quickly as you can after you make a mistake. And that is how I think you continue to stay alive and continue to scale and build a company. In our case, very specifically, as I told you, we raised our seed round in 2022. In 2023, we're actually ready to launch the initial version of our protocol. And a number of things kind of conspired, and we ended up tabling the protocol until really today. First, FTX, Terra, and then as a US based team, all of the regulatory crackdown in the US became very scary for us. I point to this as like a little bit of like a aside, but one of our investors, who's a large crypto investor, polled all the banks in the United States around who would continue to accept crypto companies as clients. And of all the banks in the United States, I think there was about 15 on that list that were willing to accept crypto companies to bank. And there were 0 that were willing to accept any company affiliated with a token issuer, which was
Wow.
pretty incredible. Yeah, pretty scary, right? Obviously, the regulation by enforcement had a pretty chilling effect. Even if you were a project that got past the regulation by enforcement and you weren't shut down, a lot of projects effectively went bankrupt by fighting the legal cases. It just wasn't a great time to be launching a protocol and a token. At the same time, one of the mistakes we made was relying on a third-party company for our meters rather than developing our energy meters in house. And that company, as all startups do, made a strategic decision to leave the focus on the residential market and go fully into the commercial market. And so our residential, meter became unsupported right as we were getting ready to launch the protocol testnet. And so we told, at the time, our very small community, look, this is, the problem today. We're going to table this, and we'll let you know when it's time for us to launch the protocol. What we're going to go do is launch the marketplace I told you about, the Web 2 marketplace that installs distributed energy resources and simplifies the installation of distributed energy resources. So our team can stay alive, build a company to sustain us. And then when we launch the protocol, have an organization that can really help scale the protocol by making these upgrades as inexpensive and accessible and simple as possible. So we did that. We launched the marketplace. We've been actively electrifying homes primarily in the Northeast today. We're starting to test electrifying homes in Texas and California. Most of the homes that we're installing upgrades are doing 2 upgrades at one time, which is great validation. So, they're doing.
And sorry, explain an upgrade. What does that mean?
So our marketplace installs the full suite of electrification products for the residential market. So solar, batteries, electric vehicle chargers, insulation, heat pumps, and electric hot water heaters. So all the devices we're talking about that are very valuable to the network, we have a marketplace of local installers that will actually install those. And our platform does the design, engineering, and procurement to really drive down the cost of those upgrades. And users can select what installer they want to work with, and that installer will actually install those devices. So it's just a aggregated, very effective, very simple way to install these distributed energy upgrades in homes and in small businesses to support the growth of the protocol.
That is, I mean, obviously these aren't you guys doing that, but that's a lot of, physical work that has to happen, right? That's also costly to do as well, right?
Well, the actual physical work is on the network of installers, right? So
Understand.
So for us, it's the work that the marketplace does is geographically agnostic and is all primarily software based. So design, engineering, and procurement is all largely software managed, which makes it quite scalable, which we're excited about.
But then are you guys recommending these partners, or how's the client source come in? Like the lead gen, is that done by the local partners? Is it done by the protocol, or a combination?
Combination. Yep. It's done by combination. Yep.
Interesting. Yeah. I mean, that's me. I mean, I understand the meter to get someone on the grid. That's sort of one hurdle. Have electrifying your house, as you call it, with that level of investment. Seems like that's another sort of multi-order of magnitude type of investment.
Totally. Well, that's the outcome that we're looking to drive at Daylight, right? Because that is at the end of the day how we alleviate constraints on energy grids and can aggregate capacity. I think uniquely though, compared to most other deep ends, is that these investments not only have the economic rationale in the term of incentives and earnings from participating in the broader network, but it also has a cost offsetting benefit in the fact that these upgrades are energy efficient and they're reducing your broader energy cost as a whole. So you have to consider kind of both sides of that as you're making these upgrades.
And so tell us about what scale you want to get to. How do you think about scale? Is it in megawatts? Is it in homes? Is it in devices sold? Like, give us some metrics of what some targets you have are.
Yeah, we wanted, megawatts is kind of the core metric for the protocol, especially on the capacity minting side. And that's what we're really looking for. So we're looking to scale, very quickly to 50 megawatts, hopefully in the first 6 months after the protocol's live, and have growth up to 1 gigawatt and beyond over the coming 2 years following that. I think it's aggressive but achievable, and if we do that, we're creating really really significant outcomes for power grids and for the network.
And if you pick your number, 100 megawatts or a gigawatt, how much of that do you think would be new generation or new electrification versus people that just buy the meter and install the meter?
I expect we'll probably, it's much easier if you already have solar and a battery, right? Or you already have a smart thermostat to just connect the meter and connect to the platform. So I expect a lot of early growth will come from existing installations. But again, our goal is not just to connect to existing installations, but expand the total market of distributed energy. So initially, I expect many will be existing installations, upwards of 90%. And hopefully over, the first 2 years of the protocol's life, we're getting closer to the 50-50 target that I'm kind of setting of existing, individuals connecting devices that already exist in the world and new devices that are actively being incentivized and deployed by people who want to come online to the protocol.
Gotcha. Interesting. And presumably, the earlier on, you have a larger number of tokens given that bonding curve. And so you're really trying to reward those early people for whether they connect. And presumably, you connect, you get one thing. Well, that's actually a question. You connect, you get one thing versus electrifying and doing new stuff. Maybe you get a different reward or something. I'm not sure if that's possible, but you can see those as either way, you're rewarding those early people significantly.
Totally. Yep. Exactly.
And help us also understand if your generate to get to this gigawatt, what does that mean in terms of like, how's that what does that give us other metrics that are relevant there in terms of, I get what that number is in terms of electricity. That means you're powering X homes. That means you would have, a significant amount of tokens locked. The network should be pretty valuable. How do you think about those type of things?
Yeah. If we have one, so I don't want to talk too much about tokens because again, like the bonding curves and stuff are not available. I will say, I think if at 1 gigawatt, we will be likely the world's largest distributed energy network that's currently aggregated. I think surpassing Tesla, and so I think that would be a pretty exciting outcome for us.
Fair enough, and for everyone that participated and got there early, which would be huge. Let's talk about DPIN overall. Any other DPIN projects that you come across, like energy or otherwise?
Oh, so many. I think incredibly highly of the ones that I think most people know, right? Helium, Hive Mapper, Demo, great teams, great products, executing incredibly well, and super engaged communities. On the newer project side, one of my favorites is Andrina, which is not public yet, or at least their company is, but their protocol is not public yet. But they're launching a protocol called Dawn, focused on effectively wireless internet service provisioning at a very, very low cost. I think they have an incredible team, incredible investors, and are super thoughtful about their approach. And so that's one that I'm very specifically excited to see come to market.
Excellent. Let's. I haven't had them on, but I should. That's had a couple of other people on it, which are in that kind of in the telco space and energy. Anybody else on the energy side?
So there is, an interesting proposal in the Helium community today. So Helium is expanding to, their network of networks vision, meaning that they want to effectively become a DAO for, DPINs to plug into and utilize their infrastructure. There's a energy DPIN out of Sweden called Sourceful that has a proposal live now today to join the Helium sub DAO as a energy sub DAO. So I know the Helium community is reviewing that. I think it's very early days for Sourceful, but it'll be interesting to see how that shakes out, and if it does end up joining Helium, what that looks like, long term.
Really interesting. Well, that is very, definitely keep an eye on that. We actually have our, the Fluence protocol is governed out of a Swiss DAO, so a Swiss association actually, and so that's, by the way, how we address some of the regulatory, uncertainty in the U.S. is sort of really divided that up.
Yep.
Which I think is a way to do it.
Well, I think it's really interesting how much the U.S. has 180'd on crypto regulation in the last 6 months. It's been a great 6 months for crypto regulation. Of course, the bill that passed the House, there's a lot of focus on, but I think one key regulatory change that most people have overlooked is the new DUNA entity law in Wyoming, which is effectively an explicit law for organizing and formalizing DAOs in the United States, to allow DAOs to do all the things that traditional organizations can do: liability protection, ability to pay taxes, all those general, corporate structuring things, but in a very decentralized way and very much purpose built for DAOs. So we'll likely be organizing actually as a DUNA in the United States, which we're pretty excited about. We'll be one of the first.
That is interesting, and especially interesting given the challenge or the federal versus state type of kind of conflict. And so that you're, hats off for fighting that fight. We just took the easy road out and said,
Totally.
We're going to be in Switzerland. That's going to issue the token. And that is where, there's actually already clear regulation, clear way to have a DAO, clear way to do it.
Yep.
But listen, the regulation has certainly moved. So, or there have been some positive developments. Let's just say I'm not sure
Sure.
that's really caught up with the rank and file of the SEC, but we will see.
I expect
Um,
we'll see hopefully a pretty clear framework in the next 2 years in the United States. I'm hopeful, but I think that's very achievable, especially depending on the election.
Yeah, no doubt, no doubt. I mean, yeah, that listen, the election is actually the best thing that's been happened to crypto in a long time. So let's hope that that momentum continues. Jason, any other projects, deep in projects in the energy space that pay a lot of attention to or want to call attention to?
Yeah, there are several. First I'll start with Glow. Glow is very interesting, and they're taking a very different approach, a very different market than we are at Daylight. And hopefully, I think there's some interesting opportunities to collaborate in the future. But Glow is effectively building crypto economic incentives to scale solar, both large installations and small installations, using effectively crypto economic guarantees to create new carbon offsets. I think that's a very interesting application of crypto, and it's a very direct application of crypto. You literally can't build the system that David and Glow are building without blockchains and crypto. I won't get too much into their economics, but if anybody wants to check it out, I highly recommend them going to the Glow website and the Glow Foundation website and starting to learn more, because I think it is a very interesting project.
Or
And I think
the Deep Pin podcast. I had David on
oh,
because
that's
he's been
right.
on here as well. Or the podcast I did with Sal from EV3, where we both talk about Glow. So,
Amazing.
or Deep Pin Day, where David has made keynote presentations. So there's a lot of resources around here to find out about Glow.
Totally. Yeah. Go check out Glow. It's really, really interesting. I think the other one I would call attention to, just because it's a big topic in the deep end space today, but Helium announced their network of networks approach, where they're attempting to become effectively a DAO governing many different types of physical infrastructure networks. And there's a proposal floating around Helium today for an energy startup in Sweden called Sourceful to join effectively as an energy network. And so I think it'll be really interesting to see where that shakes out if the Helium community approves the expansion into non-wireless markets, and we'll see where it goes. So it's exciting just to see all the innovation around tokens and organization, and what the winning models will be long term will be decided, but it's exciting to see.
Listen, Jason, how do people find you, find Daylight? How do they get on the list to buy a device? They want to participate. Give us some ways to do it.
Yeah, absolutely. So you can find me on Twitter. My handle is just at Jason Badeaux. I'll shamelessly plug myself, but we'll constantly be tweeting about Daylight. Our Daylight domain was daylight.world. So if you go to daylight.world, you can start to read about the protocol, start to learn more about our vision. We actually, our marketplace, so again, the installation marketplace where we help drive growth in the underlying protocol, is actually at godaylight.com, and it's a direct link from the daylight.world top domain. And so those are the places I would drive people to follow. We'll be active on Twitter. We'll be active on our website and our blogs. And so we hope people follow along. To get involved in the protocol itself and our testnet, which is live, you'll download the Daylight app. Initially, it'll be launched in the US, but we'll be expanding to the EU and other countries as quickly as possible. You can download the Daylight app. You can start connecting any energy devices you have in your home, whether that's a thermostat, an electric vehicle, solar panels, an inverter, battery. You can connect those directly to the app, start engaging and managing those, and start to earn points in our points campaign for connecting those devices. So that's where I would direct people to get started.
Super interesting. Listen, love what you're doing. It's important for crypto to both help the crypto narrative, and it's also important for the environment to help drive edge generation and management. So thrilled about everything you're doing. Thanks for being on, and look forward to having you on again after you've actually launched this token, things are live, and we can talk about kind of the adoption and progress and kind of how it's all managing everything from governance all the way down to deployment, token economics, everything. I'm sure you're gonna have, and the thing is you're tracking all of this, right? So it should be very easy to understand what's working, where it's working at a pretty granular level.
Totally. Well, thank you, Tom, for hosting me today, and very excited to come back on once mainnet's live, and we'll chat progress.
Fantastic. Thanks again.